Hello, in this lecture we will find the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that line segment AE equals to ED. We also know that EB equals to 7 units, line segment EB equals to 7 units, line segment BF equals to 9 units, angle ABE equals to theta, and angle EBF also equals to theta, and we want to find out the area of this green shape. Okay, so I will start with the first method, and we will extend line segment BE and also line segment CD until they intersect with each other. And we will define the intersection point, or the point that the extended line segment BE meets with the extended line segment CD. We will define it, the touching point between those two line segments, as point P. This is actually the intersection point between extended BE and extended CD, and actually we know that all the angles inside the rectangle are right angles, so actually this angle is a right angle because ABCD is a rectangle. This is a right angle. This is also a right angle. And this angle is also a right angle. And I will present to you a new rule. Rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. And actually CD is one side of rectangle ABCD, therefore it must be a straight line, and we extended the straight line CD by a straight line. Therefore CP must be a straight line. Okay, so CP is a straight line. Therefore, if we focus on this side of the straight line CP, at point D, the sum of the angles must be equal to 180 degrees. That is to say, this angle that is a right angle plus the size of this angle that we will define as angle X, the sum of those two angles must be equal to 180 degrees according to rule number 1. So, we'll write it down. So actually, this angle that is 90 degrees plus angle X must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So the sum of the angles on this side of the straight line CP must be equal to 180 degrees. So you can write down that 90 degrees plus the size of angle X must be equal to 180 degrees. Okay, so we will subtract 90 degrees from this equation, and we will get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we can substitute X by a right angle because X equals to 90 degrees. It is a right angle. So this angle is a right angle equals to 90 degrees. And we will define line segment AE, this line segment as X, and it is given us in the question that AE equals to ED. So if AE equals to ED and AE equals to X, then ED will be also equal to X. Okay? And we also have rule number 2. Actually, first of all, we know that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to CD, because those are the opposite sides of rectangle ABCD. Therefore, they are actually parallel to each other. So AB is parallel to CD. Then if AB, so we can write down that AB is parallel to CD because the opposite sides of a rectangle are parallel to each other. AB is parallel to CD, so, and we extended CD by a straight line, so therefore AB will be also parallel to CP because we extended CD by a straight line. So AB will be also parallel to CP. AB is parallel to CP. AB is parallel, here AB is parallel to CP, and we have rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. Alternating angles between parallel lines alternating angles between parallel lines are equal to each other. So I'll read rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. We can implement rule number 2 in our drawing, because in our drawing we have those two angles are defined as alternating angles. That is to say, angle ABE, that is angle theta, and also angle CPE, that is alternating angles. So those two angles are defined as alternating angles, and they are located between the parallel lines AB and CP. Therefore, according to rule number 2, they are equal to each other. So you can write down that angle ABE, this angle that equals to theta, angle ABE, equals to angle EPD, so those two angles are defined as alternating angles, and they are located between the parallel lines AB and CP. Therefore, they are equal to each other according to rule number 2. So angle ABE equals to angle EPD according to rule number 2. But we know that angle ABE, this angle, is equal to theta according to what is given us in the question. Angle ABE equals to theta. It is given us in the question. So this angle equals to theta. So from this equality, we will conclude that angle EPD also equals to theta. Angle EPD equals to theta. Angle EPD equals to theta. So actually, this angle EPD equals to theta. So in the next step, we will focus on those two triangles, and we will prove that those two triangles, they can go into each other. So we will focus on triangle ABE, the right triangle, triangle ABE, this triangle, and the right triangle, triangle EPD, this right triangle. And we will prove that those two right triangles can go into each other. I'll repeat again. We will focus on the right triangles, triangle ABE and EPD, and we will prove that they can congruent to each other. So, first of all, we just right now proved that those two angles, they are equal to each other, they are both equal to theta. So, angle ABE in the green triangle, triangle ABE, angle ABE equals to angle EPD, and both those two angles, they are equal to theta. It is given us in the question that this angle equals to theta. So angle ABE in triangle AB equals to angle EPD from triangle EPD, and they are both equal to theta. And those two angles, they are both right angles, therefore they are equal to each other. So angle ABE from the green triangle equals to angle PDE from this right angle, and both those two angles are right angles, that is to say they are equal to 90 degrees. Okay, so angle AB equals to angle PDE, they are both right angles, they are equal to each other. And those two angles, they are also equal to each other according to the rule that vertex angles are equal to each other. So this angle, angle AEB, equals to this angle, angle PED, according to the rule that vertex angles are equal to each other. Okay, those two angles are equal to each other according to the rule that vertex angles are equal to each other. So we actually proved that all three angles in the green triangles are equal to all three angles in this triangle PED, and we also it is given us in the question that AE equals to ED, and they are both equal to X according to our definition. AE equals to ED, and they are equal to X according to our definition. So we actually proved the triangle ABE congruent to triangle PDE, this triangle, according to angle side angle rule. I'll write it down. We actually proved that triangle ABE is congruent. This is the sign of congruence to triangle EPD, according to angle side angle rule. I'll repeat again. We proved the triangle ABE can go into triangle APD according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle then the triangles can go into each other according to angle side angle rule. So I'll read the rule angle side angle rule again. If two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included again the rule. If two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles can go into each other according to angle side angle rule. Okay? We actually proved that all the angles in those two triangles can go in, and they have also one side AE equals to ED. So we actually proved more than what is needed in order to prove that those two triangles can congruent to each other according to angle side angle rule. And from the fact that those two triangles can congruent to each other, we will conclude that BE equals to EP. BE equals to EP according to the rule that corresponding sides between corresponding sides in congruent triangles are equal to each other. So BE equals to EP, but we know that BE equals to 7 units. BE equals to 7 units, so from this equality we will conclude that EP also equals to 7 units. EP also equals to 7 units. So we can write here that EP equals to 7 units. So in the next step we will join points F and E together by a straight line. Actually, triangle BPE is an isosceles triangle. I'll write it down. Triangle BPE is an isosceles triangle because of the fact that both those two angles in triangle BPE, they are equal to each other, they are both equal to theta, and we have a rule we have a new rule. I will call it rule number 3. According to rule number 3, the median to the base of an isosceles triangle is also perpendicular to the base. So I will read rule number 3 again. According to rule number 3, the median to the base of an isosceles triangle is also perpendicular to the base. So what does rule number 3 means? It means that if we have an isosceles triangle, triangle ABC, so we know that triangle ABC is an isosceles triangle, that is to say those two angles, they are both equal to theta, they are equal to each other. So if from point A we will draw median to BC, that is to say the median bisects side BC, so this angle will be equal to x, and this side will define the touching point between the median and BC as point O. So BO equals to OC, they are both equal to x, because AO is the median. So because of the fact that triangle ABC is an isosceles triangle, the median not only bisects the base BC, but it is also perpendicular to the base BC, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay, so the median AO that bisects the base BC into two equal parts, it is not only bisects the side BC into two equal parts, but it is also perpendicular to the base BC, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so as you can see, FE is median in the isosceles triangle, triangle BFP, because BE equals to EP, it bisects the base BP into two equal parts. Both those parts are equal to 7 units. Therefore, according to rule number 3, it is also perpendicular to the base BC. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Okay? So actually, EF is not only the median to the base BP, but it is also the height of triangle BPF. Okay? We will define the area of the quadrilateral BEFD SY and we will define the area of the right triangle, triangle ABE as Z. So the area that we have to find is the green area, and the green area equals to Z plus Y. And it's the area equals to Z, the area that we have to find out, it equals to Z plus Y. So the green area equals to Z plus Y but because of the fact that we already proved the triangle ABE is congruent to triangle EPD, because of the fact that those two triangles congruent to each other, they also have the same area. So if the area of triangle ABE is Z, the area of triangle EPD will be also equal to Z, because congruent triangles have the same areas. Therefore, if the area of triangle ABE equals to Z, then the area of triangle PED that congruent to triangle AEB will be also equal to Z. So actually, if we will find the area of this triangle BPF, we will find the area of the green shape, because the area of triangle BPF, the area of triangle BPF equals to y plus z, z plus y. The area of triangle BPF equals to z plus y. This is the sign of the area. The area of triangle BPF equals to z plus y. We have to find the green area that is also equals to z plus y. So when we will find the area of the triangle BPF, we will find the area that we want to find, the area of the green shape that is also z plus y. So we will find the area of triangle BPF. The area of triangle BPF, the area of any triangle equals to the base of the triangle times the height to the base over 2. First of all, we will focus on the right green triangle, triangle BEF. On the right green triangle, triangle BEF, on triangle BEF, the right triangle, triangle BEF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So the hypotenuse is BF. So BF square equals to BE square plus EF square. I repeat again, in the green right triangle, triangle BEF, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to EB square plus EF square. BF equals to 9 units. If BF equals to 9 units, then BF square is 9 square. 9 square is 81, equals to BE square. BE equals to 7 units. Therefore, BE square is 7 square. 7 square is 49 plus EF square. So, in conclusion, we found out that 81 equals to 49 plus EF square. 89 minus 81 minus 49 is 32. So We subtract 49 from this equation number 1. 81 minus 49 is 32. 32 equals to EF squared. We take a root out of this equation number 1. EF equals to the square root of 32, and 32 is 16 times 2. The square root of 16 is 4. So actually we found out that EF equals to 4 times square root of 2 units. EF equals to 4 times square root of 2 units. And the area of triangle BPF equals to the base of the triangle times the height to the base over 2. So the area of triangle BPF equals to the base, that is actually BP. The base is BP, times the height to the base. The height is EF, over 2. So according to equation number 2, the area of triangle BPF equals to BP. BP is 7 plus 7 is 14. BP equals to 14. EF equals to 4 times square root of 2. Over 2. So the area of triangle BPF equals to 14 over 2 is 7. 7 times 4 times square root of 2, that is to say it equals to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I'll repeat again. The area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. So the area of this green shape equals to either 28 times square root of 2 units, or in terms of numbers it equals to 39.6 square units. We finished with the first method, so we will continue with the second method. In the second method, we will actually relate. We know that AB AB is parallel to DC because the opposite sides of a rectangle are parallel to each other. AB is parallel to DC. And because of the fact that AB is parallel to DC, AB also will be parallel to FC. AB is parallel to FC. And actually, this angle ABF, it equals to theta plus theta is 2 theta. Angle ABF equals to theta. And this angle is angle BFC. According to the rule that alternating angles between parallel lines are equal to each other, so those two angles, they are equal to each other. Why? Because there are two alternating angles that are located between the parallel lines AB and DC. Therefore, they are equal to each other. So if this angle is 2 theta, then this angle will be equal to 2 theta also. And we also know that all the angles inside a rectangle, they are right angles. That is to say, this angle is a right angle. This angle is also a right angle. And this angle, it is also a right angle. We will define AE as x. AE equals to x according to our definition. It is given us the question that, so AE equals to x, and it is given us the question that AE equals to ED, okay? AE equals to ED. So if AE equals to x, then ED will be also equal to x. And we also know that the opposite sides of a rectangle are equal to each other. So if AD equals to x plus x, that is to say AD equals to 2x, then BC will be also equal to 2x. Okay? So we will focus on the right triangle, triangle BAE. This right triangle, triangle BAE. On the right triangle, triangle BAE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, that is to say, BE square, this is the square of the hypotenuse, is BE square. But before that, we know that sinus theta equals to x over 7. In the right triangle BAE, sinus theta equals to x over 7. Sinus theta equals to x over 7. You can see sinus theta in the right triangle BAE equals to x over 7. And if we relate to the right triangle, triangle BFC, in the right triangle, triangle BFC, sinus 2 theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. But we also have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosinus theta, and we actually found out that sinus 2 theta equals to 2x over 9. So we can write here that sinus 2 theta that equals to 2x over 9 equals to 2 sinus theta cosinus theta and we have already found out that sinus theta equals to x over 7. So here sinus theta equals to x over 7. So it is 2x times cosinus theta. It equals to 2x over 9. I substituted sinus theta by x over 7 because as I already showed you, sinus theta equals to x over 7. So here we have 2x in both sides of equation number 2, so we'll cancel 2x. 2x will get cancelled. In conclusion, we will get that according to equation number 2, 1 over 9 equals to cosinus theta over 7. We will multiply this equation number 2 by 7, and we will get that cosinus theta equals to 7 over 9. Cosinus theta equals to 7 over 9. And as you already know, cosinus is the relationship between the sides of a right triangle. Okay, so the function cosinus is the relationship between the sides of a right triangle. So actually, if we have right triangle with angle theta, like this, we found out that cosinus theta equals to 7 over 9. It means that if this angle in this right triangle is theta, then the side that is near angle theta equals to 7 units, and the hypotenuse equals to 9 units. And if we define this side as side S, then we will get that according to Pythagoras theorem, S squared, 7 squared plus S squared equals to 9 squared. So S squared equals to 9 squared, it is 81, minus 7 squared, it is 49. So S squared equals to 32. S equals to square root of 32. 32 is 16 times 2. The square root of 16 is 4. So we actually found out that S equals to 4 times square root of 2. So we can write down that we know that we have already found out that cosinus theta equals to 7 over 9, and as you can see in this, from this right triangle, sinus theta will be equal to 4 times square root of 2 over 9. Okay, sinus theta equals to 4 times square root of 2 over 9. So we found out the values of sinus theta and cosinus theta, and we know that here sinus theta equals to x over 7. In this right triangle, sinus triangle ABE, sinus theta equals to x over 7. In the right triangle, triangle ABE, sinus theta equals to x over 7. But we have already found out that sinus theta is 4 times square root of 2 over 9. So we can substitute sinus theta by 4 times square root of 2 over 9, and it equals to x over 7. We will multiply this equality by 7 in order to find out the value of x, and we will get that x equals to 7 times 4 is 28 times square root of 2 over 9. So we actually found out that x equals to 28 times square root of 2 over 9. If x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. Here also x equals to 28 times square root of 2 over 9. So in total, AD equals to 56 times square root of 2 over 9. And cosinus theta, if you focus on this right triangle, triangle ABE, in the right triangle, triangle ABE, cosinus theta this right triangle equals to AB over 7. In the right triangle, triangle ABE, cosinus theta equals to AB over 7. We have already found out that cosinus theta equals to 7 over 9. So 7 over 9 equals to AB over 7. We will multiply this equation by 7 in order to get the value of AB. AB will be equal to 49 over 9. 7 times 7 is 49, so AB equals to 49 over 9. 49 over 9. This is the value of AB. So here we will implement the Pythagoras theorem on the right triangle, triangle BFC, in order to find out the value of FC. So if you focus on the right triangle, triangle BFC, according to the Pythagoras theorem, we don't need even the Pythagoras theorem. We can say that cosinus theta, cosinus 2 theta equals to FC over 9. Okay, in the right triangle, triangle BFC, cosinus 2 theta equals to FC over 9. We will multiply this equation by 9 and we will get that FC equals to 9 times cosinus 2 theta. We have the trigonometric identity that states that cosinus theta equals to 2 times cosinus square theta minus 1. So we will substitute cosinus 2 theta in this equation by 2 times cosinus square theta minus 1. We know that cosinus theta equals to 7 over 9. If cosinus theta equals to 7 over 9, then cosinus square theta equals to 7 over 9 square. 2 times minus 1 times 9. So FC equals to 9 times FC equals to 9 times 2. 7 square is 49 over 9 minus 1 . 9 square is 81. Made a mistake, it is 81. Here we will multiply 1 by 81 and then we will divide it by 81 in order to have a common factor with this expression. And we will get that FC equals to 9 times 2 times 49 is 98 minus 81 over 81. Here 9 over 89 is 1 over 9, so FC equals to, in the denominator we have 9, and 98 minus 81 is 17. Okay, so we found out that FC equals to 17 over 9. FC equals to 17 over 9. So what is the value of df? df equals to dc minus fc. dc minus fc equals to df. dc minus fc equals to df. So df equals to dc. We have already found out, we know that the opposite sides of a rectangle are equal to each other. So if AB equals to 49 over 9, then DC will be also equal to 49 over 9 because of the fact that AB equals to DC. It is 49 over 9. So DC is 49 over 9. And FC is 17 over 9. (49 minus 17 is 32 over 9. So DF equals to 32 over 9. DF equals to 32 over 9. And we know that the area of any trapeze is equals to the sum of its sides times the height, that is to say AB plus DF times the height, that is AD, over 2. So the area of trapeze ABDF I repeat again, the area of trapeze ABDF equals to AB plus DF times AD over 2. Okay, so it equals to 1 over 2. AB equals to 49 over 9. DF equals to 32 over 9. Times AD equals to 56 times square root of 2 over 9. So in conclusion, we got AB equals to 49 over 9. DF equals to 32 over 9. And AD equals to 56 times square root of 2 over 9. So we get that the area of the trapeze ABDF equals to 1 over 2. Here we have 81 over 9 times 9 times 56 times square root of 2. So 9 times 9 is 81. 81 over 81 is 1. And the area of the trapeze ABDF, that is the area of the green shape, equals to 28 times square root of 2 units. So in terms of numbers, it's 39 times 6 square units. I'll repeat again. The area of the green shape or trapeze ABDF equals to either 28 times square root of 2 square units, so in terms of numbers it equals to 39.6 square units. So we finished with the second method. We continue in the third method. So in the third method, we will draw perpendicular from point A to BF. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from A to BF as point M. Then we will prove that those two, actually all the angles of a square, of a rectangle ABCD are right angles. They are all equal to 90 degrees. So those angles are right angles. We will prove that those two triangles can go into each other. That is to say, we will prove that triangle ABE is congruent to triangle BEM. I'll repeat again. We will prove that triangle ABE is congruent to triangle BEM. So, first of all, those two angles, they are both equal to theta, therefore they are equal to each other. So, angle ABE of triangle ABE equals to angle EBM and they are both equal to theta. Okay, angle ABE equals to angle EBM and they are both equal to theta according to what is given us in the question. Those two angles, they are both right angles, therefore they are equal to each other. So angle BAE equals to angle BME, and they are both equal to 90 degrees. Okay, angle BAE equals to angle BME, and they are both equal to 90 degrees. They are right angles. And those two angles, they are equal to each other according to third angle theorem. So angle BEA, this angle, equals to angle BEM, this angle, according to third angle theorem. So, what is the third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And we proved that those two angles are equal to those two angles. Therefore, the third pair of angles must also congruent according to third angle theorem. Okay, so we actually proved the triangle ABE is congruent to triangle BEM, and before that, BE equals to BE. It is a common angle. First of all, before that, we prove that all three angles in triangle ABE congruent to all three angles in triangle BEM, and we also have a common side. BE equals to BE. It is a common side. BE equals to BE. It is a common side. It belongs to both triangles. Okay. BE equals to BE. It is a common side that belongs to both triangles. So we actually proved the triangle ABE congruent to triangle BEM according to angle side angle rule. I will already explain to you what is angle side angle rule, so I will not repeat it. And triangle ABE is congruent. This is the sign of congruent to triangle BEM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that side AB of triangle ABE equals to side BM of triangle EBM. AB equals to BM. AB equals to BM. AB equals to BM according to the rule that corresponding sides in congruent triangles are equal to each other. And if we define AB as Y, then BM will be also equal to Y. If BM equal to Y, then MF, and we know that BF equals to 9 units, it is given us in the question. So BM will be equal to 9 minus Y, because of the fact that BF minus BM equals to MF. BF is 9 units, BM is Y, so MF will be equal to 9 minus Y. We will join together points E and F by a straight line. And from the fact that those two triangles can go into each other, we will also conclude that AE equals to EM. AE equals to EM. AE equals to EM according to the same rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding sides will be also equal to each other. And if we define AE as X, then EM will be also equal to X. And because of the fact that AE equals to ED, then, and we know that AE equals to X, then ED will be also equal to X. In the next step, we will prove that those two triangles can go into each other. So we will focus on triangle EMF. And triangle EDF. And we will prove that those two triangles can go into each other. Actually, they are right triangles. First of all, we know that EM equals to ED they are both equal to x units according to our definition. EM equals to ED, EM equals to ED equals to x, EM equals to ED equals to x, according to our definition. EF is a common side, it belongs to both triangles. So EF equals to EF, EF equals to EF is a common side. So EF equals to EF, it is a common side that belongs to both triangles. And angle, those two angles, they are both right angles, therefore they are equal to each other, they are both equal to 90 units. So angle EMF, here equals to angle FDE, and they are both equal to 90 units. Okay, angle EMF equals to angle FDE, and they are both equal to 90 units. So actually, by proving those two things, we actually proved that triangle EMF is congruent. Triangle EMF is congruent to triangle EDF, according to triangle EMF congruent to triangle EDF according to the following rule. We call it rule number 5. According to rule number 5, if the hypotenuse and a perpendicular in two right triangles congruent, then the right triangles congruent to each other. We will read rule number 5 again. According to rule number 5, if the hypotenuse and a perpendicular in two right triangles congruent, then the right triangles congruent to each other. So from the fact that those two right triangles congruent to each other, we will conclude that MF equals to DF. MF equals to DF. So MF from triangle MEF equals to DF from triangle EDF, according to the rule that corresponding sides in congruent triangles are equal to each other. But we know that MF equals to 9 minus y. MF equals to 9 minus y. I'll repeat again. Because of the fact that the two triangles congruent to each other, we will conclude that MF equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. And because of the fact that MF equals to 9 minus y, we will conclude that DF also equals to 9 minus y. DF also equals to 9 minus y. And we also know that opposite sides of a rectangle are equal to each other, and we define AB as y. If AB equals to y, then DC will be also equal to y because of the fact that AB and DC are two opposite sides, and therefore two opposite sides in a rectangle are equal to each other. So DC will be also equal to y. DC will be also equal to y because of the fact that AB equals to DC also equals to y, and CF equals to DC minus DF. CF equals to DC minus DF. I'll repeat again. CF equals to DC minus DF. So CF equals to DC is y, minus DF is 9 minus y. So CF equals to DC, that is y, minus DF, that is 9 minus y. So we will open the brackets, we will get that CF equals to y minus 9 minus y is plus y. So in conclusion, we found out that CF equals to 2y minus 9. CF equals to 2y minus 9. CF equals to 2y minus 9. And according to the rule that the opposite sides of a rectangle are equal to each other, ABCD is a rectangle, so AD equals to BC. AD equals to x plus x, that is to say to 2x, so BC will be also equal to 2x. So BC equals to 2x, CF equals to 2y minus 9, and BF equals to 9. So we will implement the Pythagoras theorem on this right triangle, triangle BAE. Okay, in this right triangle, triangle BAE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BE square equals to AB square plus AE square. I'll repeat again, in the right triangle, triangle BAE, according to the Pythagoras theorem, BE square equals to AB square plus AE square. BE is 7, so BE square is 7 square, 7 square is 49. 49 equals to AB square. AB square is y square plus AE square is x square. So in conclusion, we found out that according to equation number 1, x square plus y square equals to 49. We will focus on this right triangle. We will implement the Pythagoras theorem on the right triangle, triangle BFC. this right triangle BFC. According to the Pythagoras theorem, in the right triangle BFC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to CF square plus BC square. I'll repeat again, in the right triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF square equals to CE square plus BC square. BF equals to 9. BF equals to 9 units according to what is given us in the question. So BF square is 9 square. 9 square is 81. 81 equals to CF square. CF is 2y minus 9. So CF square is 2y minus 9 square plus BC square. BC is 2x, so BC square is 4x square. Okay? So in conclusion, we found out that 81 equals to 2y minus 9 square plus 4x square. We will open the brackets on this side of the equation, and we will get that 81 equals to 4y square plus 81 minus 36y plus 4x squared. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and we will take a common factor of 4 from y squared and 4x squared, and we will get that 0 equals to 4 times x squared plus y squared minus 36y. We will add to this equation number 2, 36y, and we will get that 4 times x squared plus y squared equals to 36y. We got that 4 times x squared plus y squared equals to 36y. But we have already found out that according to equation number 1, x squared plus y squared equals to 49. So we will substitute x squared plus y squared by 49, and we will get that 4 times 49 equals to 36y. We will divide this equation number 2 by 4, and we will get that 9y equals to 49. We will divide this equation by 9, and we will get that y equals to 49 over 9. Y equals to 49 over 9. And according to equation number 1, x squared plus y squared equals to 49. So we will place the value of y inside this equation number 1, inside y squared. We will get that x squared plus y is 49 over 9. Y squared is 49 over 9 squared equals to 49. So we get that x squared equals to 49 minus 49 over 9 squared. We know that 49 is 7 squared. So we substitute 49 by 7 squared, and we will get that according to equation number 1, x squared equals to 7 squared minus 49 over 9 squared, and according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. Here b squared is 0, so we get that x squared equals to a plus b times a minus b. A is 7 and b is 49 over 9, so it is 7 plus 49 over 9 times 7 minus 49 over 9. So x squared equals to, we will multiply 7 by 9 and then we will divide it by 9 in order to have a common factor with this expression, and we will get that 63 plus 49 over 9. We'll do the same thing here. It is 63 minus 49 over 9. So here x squared equals to 112 times 14 over 9 times 9. Okay. Actually we got, according to equation number 1, that x squared equals to 112 is 14 times 8, 14 times 8 times 14 over 9 times 9. So here we will substitute 8 by 2 times 2 times 2, and we will get that x squared equals to 14 times 14, 2 times 2 times 2 over 9 times 9. Here we'll take a root out of this equation number 1, and we will get that x equals to the square root of 14 times 14, 2 times 2 times 2 over 9 times 9. So actually x equals to 14, the square root of 14 times 14 is 14, and the square root of 2 times 2 is 2, so what is left inside the root is only 2, and the square root of 9 times 9 is 9. So in conclusion, we got that according to equation number 1, x equals to 28 over 9 times square root of 2, and we have already found out that y, according to equation number 2, y equals to 49 over 9. So in conclusion, we found out that x equals to 28 over 9 times square root of 2 and y equals to 49 over 9. And what is the area of the trapeze ABDF, that is actually also the green shape? The area of trapeze ABDF equals to AB plus DF times the height, that is AD, times 1 over 2. So the area of trapeze ABDF equals to 1 over 2 times AB plus DF times AD. So the area of trapeze ABDF, that is the green shape that we want to find the area of it, equals to 1 over 2 AB is 2x, AB is y. AB is y. As you can see, AB is y plus DF. DF is 9 minus y times AD. AD is 2x So in conclusion, the area of trapeze ABDF equals to 1 over 2 y minus y is 0, and 2 over 2 is 1. So in conclusion, we found out that the area of trapeze ABDF equals to 9x. The area of trapeze ABDF equals to 9x, and we have already found out that x equals to 28 over 9 times square root of 2. Here 9 over 9 is 1, so 9 will get cancelled, and we found out that the area of trapeze ABDF equals to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. I'll repeat again. We found out that the area of trapeze ABDF is equal to either 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the area of the green shape. It is actually also trapeze ABDF, and in the first method, actually in the first method, we extended line segment BE and line segment CD until they intersect with each other at point P, and then we actually proved that those two triangles can go into each other. Actually, I presented to you rule number 1, rule number presented to you rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that CD is one side of rectangle ABCD, therefore it is absolutely a straight line. And then we extended the straight line CD by a straight line, so CP will be still a straight line. So on this side of the straight line CP, the sum of the angles at point D will be equal to 180 degrees. So this angle is 90 degrees plus the size of this angle that we defined as angle X must be equal to 180 degrees. The angle that equals to 90 degrees plus the size of angle X must be equal to 180 degrees according to rule number 1. We subtracted 90 degrees from this quantity and we got that angle X equals to 90 degrees. That is to say this angle is a right angle. Okay. We know that AB is parallel to CP. Because of the fact that AB is parallel to CD, according to the rule that the opposite sides of a rectangle are parallel to each other, and we extended CD by a straight line, therefore AB will be still parallel to CP, and because of the fact that AB is parallel to CP, then those two angles that are alternating angles that are located between the parallel lines AB and CP will be equal to each other, according to rule number 2 that states that alternating angles between parallel lines are equal to each other. I'll repeat again. Those two angles are defined as alternating angles that are located between the parallel lines AB and CP, therefore they are equal to each other. And we know that this angle equals to theta, so this angle that will be also equal to theta. Okay, so actually angle EPD equals to theta. So this angle equals to theta. Then we proved that those two triangles can go into each other. Triangle ABE, this triangle ABE is congruent to triangle EPD. We proved that those two triangles can go into each other. Why they can go into each other? Because AB equals to EPD, ABE, those two angles, we just right now prove that those two angles are equal to each other, they are both equal to theta. And those two angles, that is to say angle AB equals to angle PDE, they are both equal to 90 degrees, they are right angles. And also those two angles are also equal to each other according to the rule that vertex angles are equal to each other. So all the angles inside triangle EPD can go into all the angles inside triangle AEB, and we also know that AE equals to ED according to what is given us in the question, that AE equals to ED. Therefore, we actually proved that triangle ABE is congruent to triangle EPD according to angle side angle rule. What is angle side angle rule? Angle side angle rule is that says that if two angles in the side that included between those two angles in one triangle congruent to two angles in the side that included between them in another triangle, between those two angles in another triangle, then the triangles can go into each other according to angle side angle rule. Okay? And because of the fact that those two triangles can go into each other, we will conclude that EB equals to EP. EB equals to EP. But we know that it is given us in the question that EB equals to 7 units, so therefore EP will be also equal to 7 units. EB equals to 7 units, therefore from this equality we will conclude that EP also equals to 7 units. Okay? So because of the fact that those two, if we focus on triangle PBF, this triangle, you know that those two angles, they are equal to each other, they are both equal to theta, therefore triangle PBF is a right triangle because it has two angles that are equal to each other. Again, triangle PBF is an isosceles triangle because it has two angles that are equal to each other. And then we have rule number 3. According to rule number 3, the median to the base of an isosceles triangle is also perpendicular to the base. So if triangle ABC is an isosceles triangle because it has two angles that are equal to each other, and the base is BC. From point A, we draw median to the base BC. The median, of course, bisects BC, that is to say BO equals to OC. They are both equal to X units, but it is not only bisects. The median not only bisects the base BC, but it is also perpendicular to the base BC. So whenever you have a isosceles triangle, then the median to the base not only bisects the base, but it is also perpendicular to the base. That is to say, AO is perpendicular to BC. This angle equals to 90 degrees, and this angle also equals to 90 degrees. And because of the fact that we have this isosceles triangle, EF is a median. Why is a median? Because it bisects the base PB into two equal sides. This PE equals to 7 units and BE also equals to 7 units. So FE is the median to the base PB of the isosceles triangle PBE, and according to rule number 3, it is not only bisects PB into two equal sides, but it is two equal parts, but it is also perpendicular to the base PB. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? Okay, so the green, okay, so this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact, so we defined the area of quadrilateral EBDF as y, so this area equals to y, and because of the fact that triangle PED is congruent to triangle AEB according to angle side angle rule, and those two congruent triangles have also equal areas. So if the area of the green triangle equals to Z, then the area of the congruent triangle, triangle PED, that is congruent to ABE, will be also equal to Z units. So the area that we have to find is the green area. The green area equals to Z plus Y, but because of the fact that the area of triangle PFB also equals to Z plus Y, so if we calculate the area of triangle PBF, we will actually find out the area of the green shape, the area of the green trapeze. So we'll find out the area of the triangle PBF, and in this way we'll find out actually the area of the green shape that we want to find out. Okay, and we know that the base of the triangle PBF equals to 14 units. The only thing that is left to find in order to find out the area of triangle PBF is to find out the area of the height EF. And we'll find out the area of the height EF according to, by implementing the Pythagoras theorem in the green triangle, triangle EFB. Okay, in the green triangle, triangle EFB, or according to the Pythagoras theorem, BE square equals to BF square equals to BE square plus EF square. BF square equals to EB square plus EF square. So BE is 9, so BE square is 81. BF is 7, so BE square is 49, plus EF square. We subtracted 49 from this equation, equation number 1. 81 minus 49 is 32. So 32 equals to EF square. We took a root out of this equation, equation number 2, and we got that EF equals to the square root of 32. 32 is 16 times 2. The square root of 16 is 4 times 2, so EF equals to 4 times 2 units. So we found out that EF equals to 4 times 2 units, and we know that the base PB equals to 14 units. So we can easily find out the area of the triangle PBF, that is actually the area of the green shape also. According to the, we know that the area of any triangle equals to the base of the triangle times the height over 2. Therefore the area of triangle BPF will be equal to the base times the height over 2. The base of triangle PBF is PB and the height is FE, so PB times EF over 2 is the area of triangle PBF. PB times EF over 2 is the area of triangle PBF. PB equals to 14 units. We have already found out that EF equals to 4 times square root of 2 units. So it is 14 times 4 times square root of 2 over 2. 14 over 2 is 7. So the area of triangle EBPF equals to 7 times 4 times square root of 2 units, square units. That is to say the area of triangle PBF, that is also the area of the green shape, it equals to 22 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. That was method number 1. Then we found out the area of the green shape according to the second method. According to the second method, according to the second method, we know that AB is parallel to CD because of the fact that ABCD is a rectangle. So if AB is parallel to CD, AB is also parallel to CF because CF is part of CD. So those two angles are located between the parallel sides AB and CF, and therefore they are equal to each other according to the rule that alternating angles between parallel lines are equal to each other. Those two angles are alternating angles and they are located between the parallel lines AB and CF, therefore they are equal to each other. So if this angle equals to 2 theta, then this angle will be also equal to 2 theta. Okay? AB is parallel to DC because the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, then AB will be also parallel to CF. Okay? And according to the rule that alternating angles between parallel lines are equal to each other, those two angles are equal to each other. So if this angle is 2 theta, this angle will be also equal to 2 theta. Okay? We defined AE as x, therefore ED will be also equals to x because AE equals to ED according to what is given us in the question. So in triangle BAE, this right triangle BAE, we know that sinus theta equals to AE over ED. Sinus theta equals to AE over ED, that is to say AE equals to x, so sinus theta equals to x over 7, and in the right triangle BFC, you know that sinus 2 theta equals to BC over CF. BC, because of the fact that AD is equal to BC, because the opposite sides of a rectangle are equal to each other, so AD equals to 2x, then BC will be also equal to 2x, so sinus 2 theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. And we already found out that sinus theta equals to x over 7. But sinus 2 theta is equal to 2 sinus theta cosinus theta according to the algebraic identity. Sinus 2 theta equals to 2 sinus theta cosinus theta. And we have already found out that sinus 2 theta equals to 2x over 9, so we can substitute sinus 2 theta by 2x over 9, and it equals to 2 sinus theta cosinus theta. So 2x over 9 equals to 2 sinus theta, and we have already found out that sinus theta equals to x over 7 times cosinus theta. Here we have 2x on both sides of the equation, number of 2, and 2x will get cancelled. In conclusion, we found out that 1 over 9 equals to cosinus theta over 7. We multiplied this equation number 2 by 7, and we found out that cosinus theta equals to 7 over 9. Cosinus theta equals to 7 over 9. And what is the meaning that cosinus theta equals to 7 over 9? Cosinus theta is the relationship between the sides of a right triangle. Cosinus theta equals to 7 over 9. It means that we have a right triangle with one angle is theta, the perpendicular is 7 units, and the hypotenuse is 9 units. That is the meaning that cosinus theta equals to 7 over 9. Then we found out the value of this side according to the Pythagoras theorem. 7 square plus s square equals to 9 square. Then we subtract that 7 square, that is 49, from this equality, and we got that s square equals to 9 square, this is 89, plus minus 7 square, this is 49. So f square equals to 81 minus 49, this is 32. So s equals to the square root of 32. 32 is 16 times 2, then square root of 16 is 4. So in conclusion, we found out that s equals to 4 times 2. S equals to 4 times 2. And if s equals to 4 times 2, then sinus theta will be equal to 4 times 2 over 9. Okay, sinus theta will be equal to 4 times 2 over 9. Okay, sinus theta equals to 4 times 2 over 9, and we have already found out that cosinus theta equals to 7 over 9. So in the right triangle, triangle ABE, we have already found out that sinus theta equals to x over 7, but we have already found out that sinus theta equals to 4 times square root over 2 over 9. We substituted sinus theta by 4 times square root of 2 over 9. We multiplied this equation by 7, and we found out that x equals to 29 times square root of 2 over 9, 28 times square root of 2 over 9. So here x equals to 28 times square root of 2 over 9, and if x equals to 28 times square root of 2 over 9, then 2x, that is actually AD, that is also equals to BC, will be also equal to 56 times square root of 2 over 9. Then we focused on the right triangle, triangle ABE. On the right triangle, triangle ABE, cosinus theta equals to AB over 7. Cosinus theta equals to AB over 7. but we know that cosinus theta equals to 7 over 9, so we can substitute cosinus theta by 7 over 9, so 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we found out that AB equals to 49 over 9. So AB equals to 49 over 9 and BC equals to 56 times root of 2 over 9. Okay, then we found out the value of CF according to the equation that cosinus theta equals to CF over 9. Cosinus 2 theta equals to CF over 9. We multiplied this equation by 9 and we got that FC equals to 9 times cosinus theta, and we have the trigonometric identity that cosinus 2 theta equals to 2 cosinus square theta minus 9. So we substituted cosinus 2 theta by 2 cosinus square theta minus 1 in this equation, and we got that FC equals to 9 times 2 cosinus square theta minus 1. But we know that cosinus theta equals to 7 over 9, so if cosinus theta equals to 7 over 9, then cosinus square theta will be equal to 7 over 9 square. So FC equals to 9 times 2 times 7 over 9 square minus 9. So FC equals to 2 times 7 square is 49 and 8 square is 81. So in conclusion, we found out that FC equals to 9 times 2 times 49 over 81 minus 1. Then we multiplied 1 by 81 and then we divided by 81 in order to have a common factor with this expression, and we got that FC equals to 9 times 49 times 2 is 98 minus 81 over 81. 98 minus 81 is 17, and here we divided 81 by 9 and we got that FC equals to 17 over 9. So we found out that FC equals to 17 over 9, and we know that DC equals to 49 over 9, so DC minus DF, DC minus CF equals to DF. Okay, DF equals to DC minus FC, so DF equals to DC is the 49 over 9, FC is 17 over 9, so in conclusion DF equals to 49 over 9 minus 17 over 9 is 32 over 9. So DF equals to 32 over 9. Okay, so actually we have all the variables that we need in order to find out the area of the green trapeze. So the area of the green trapeze ABDE equals to 1 over 2 AB plus DF times AD, that is the height, over 2. Yes, AB is 49 over 9 and DF is 32 over 9 times the height AD is 56 times square root of 2 of 56 times square root of 2 over 9. Okay, so here 49 plus 32 is 81, so here it is 81 over 9 times 56 times square root of 2 over 9. So here we have 9 times 9 in the denominator and 81 in the numerator, so 81 over 81 is 1. So the area of trapeze ABDE equals to 56 over 2 times square root of 2, that is to say the area of the green shape the green trapeze ABDF equals to 28 times square root of 2 units, or in terms of numbers it equals to 39 minus 6 square units. That was the second method. Then we found out the area of the green shape according to the third method. According to the third method, we actually did another construction. We did another construction. Here we, from point E, we go perpendicular to BF, so this angle equals to 90 degrees and this angle also equals to 90 degrees. And then we proved that those two triangles can go into each other. We proved the triangle ABE is congruent to triangle EBM. First of all, we know that angle ABE equals to angle EBM equals to theta. And those two angles, they are both equal to theta according to what is given us in the question. Angle BAE equals to angle BME equals to 90 degrees. Those two angles are right angles, they are both equal to 90 degrees, therefore they are equal to each other. And the third angle, those two angles are also equal to each other according to third angle theorem. Okay, so what is third angle theorem? Third angle theorem says that if you have two angles in one triangle that can go into two angles in another triangle, then the third angle, the third pair of angles must also congruent. Okay, and we have already proved that those two angles congruent to those two angles, therefore the third pair of angles must also congruent according to third angle theorem. And we also know that EB equals to EB, it is a common side. It belongs to both triangles. So we actually proved that triangle ABE is congruent to triangle BEM according to angle side angle rule. I've already explained what is angle side angle rule, so I will not repeat on it. And because of the fact that those two angles congruent to each other, those two triangles congruent to each other, we will conclude that those two sides are equal to each other. That is to say, AB equals to BM, according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides will be also equal to each other. That is to say, AB equals to BM. AB equals to BM, and also from the same reason, AE equals to EM. And we know that AE equals to X, therefore AEM will be also equal to X. AE equals to EM, and because of the fact that AE equals to X, then AEM will be also equal to X. Then we join together points E and F by a straight line, and we proved that those two triangles can go into each other. So triangle EMF congruent to triangle EDF. Those two triangles congruent to each other. Why those two triangles congruent to each other? Because EM equals to DE equals to X. EM equals to DE equals to X. We know that, so EF also equals to EF, it is a common side. And angle EMF equals to angle EDF equals to 90 degrees. Those two angles they are both right angles, therefore they are equal to each other. Actually, in this way we prove that those two triangles can go into each other. We prove the triangle EMF is congruent to triangle EDF according to the following rule. According to the rule that states that if the hypotenuse and the perpendicular in two right triangles congruent, then the right triangles can go into each other. And we actually proved that the hypotenuse is a common side, and also the perpendicular EM equals to the perpendicular ED. So we proved that the hypotenuse and the perpendicular in this triangle can go into the hypotenuse and the perpendicular in this right triangle. Therefore, we proved that those two triangles can go into each other. And from the fact that those two triangles can go into each other, we will conclude that we will conclude that MF equals to DF. MF equals to DF. MF, what is the value of MF? MF equals to BF minus MB. That is to say, it equals to 9 minus Y. And because of the fact that MF equals to 9 minus Y, then DF that equals to it also will be equal to 9 minus Y. And CD minus DF equals to CF. CD equals to Y. And DF equals to 9 minus Y. Therefore, CF will be equal to 2Y minus 9. Okay? CF equals to DF minus DC minus DF. CF equals to Y minus 9 minus Y. That is to say, CF equals to Y minus 9 plus Y. That is to say, CF equals to 2Y minus 9. CF equals to 2Y minus 9. Then we focused on this triangle BAE, and we implemented the Pythagoras theorem on this right triangle BAE. According to the Pythagoras theorem, EB squared, that is actually 7 squared, equals to AE squared plus AB squared. BE squared equals to AB squared plus AE squared. BE equals to 7, so BE squared is 7 squared. 7 squared is 49. Equals to AB squared. AB is x, so AB squared is x squared. AE is y, so AE squared is y squared. So in conclusion, we found out that according to equation number 1, 49 equals to x squared plus y squared. Then we focused on the right triangle CFB. We implemented the Pythagoras theorem on this right triangle CFB. According to the Pythagoras theorem, BF squared equals to CF squared plus BC squared. BF equals to 9. Therefore, BF squared is 9 squared. 9 squared is 81. CF equals to 2y minus 9. So CF squared will be equal to 2y minus 9 squared plus BC squared. BC equals to 2x. So BC squared will be equal to 4x squared. Here we open the brackets on both on this side. On the brackets on this side of the equation number 2, and we found out that 81 equals to 4y squared plus 81 minus 36y plus 4xy. We have 81 on both sides of the equation number 2, so 81 will get cancelled. In conclusion, we found out that 0 equals to 4 times x squared plus y squared minus 36 xy, but we know that according to equation number 1, x squared plus y squared equals to 49, so we can substitute x squared plus y squared in equation number 2 by 49. So we did it, and we got that, okay, 4 times x squared plus y squared equals to 36y, and we substituted x squared plus y squared by 49, and we got that 4 times 49 equals to 36y. Here we divided this equation by 4 and we got that 49 equals, we got that 36y over 4 is 9y. So 9y equals to 49. We divided this equation number 2 by 9 and we got that y equals to 49 over 9. So we found out the value of y. And we have equation number 1 that states that x squared plus y squared equals to 49. So we can place the value of y inside y squared in equation number 1 from equation number 2. And we got that x squared plus y is 49 over 9. So y squared is 49 over 9 squared equals to 49. So we got that x squared equals to 49 minus 49 over 9 squared. Then we got that x squared equals to 7 squared minus 49 over 9. And according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b. Here b squared is 0. So here a equals to 7 and b equals to 49 over 9. So x squared will be equal to a plus b is 7 plus 49 over 9 and a minus b is 7 minus 49 over 9. That is to say x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9. Here we multiplied 7 by 9 and then we divided by 9 in order to have a common factor with this expression. So in conclusion we found out that x squared equals to 63 plus 49 over 9 times 63 minus 49 over 9. So x squared equals to 63 plus 49 is 112 over 9 times 63 minus 49 is 12, is 14 over 9. So we have 112 times 14 over 9 times 9, and 112 is 14 times 8, so we substituted 112 by 14 over 9, and we got that 14 times 9. 112 is 14 times 9, so we substituted 112 by 14 times 112 is 14 times 8, so we substituted 112 by 14 times 8. So in conclusion we got that 14 times 8 times 14 over 9 times 9 equals to x squared, and we know that 8 equals to 2 times 2 times 2. So in conclusion we found out that x squared equals to 14 times 14 times 2 times 2 times 2 over 9 times 9. We took a root out of this equation number 1, and we got that x equals to 14 times 14 times 2 times 2 times 2 over 9 times 9. Then the square root of this expression equals to the square root of 14 times 14 is 14, the square root of 2 times 2 is 2, and the square root of 9 times 9 is 9. So in conclusion we found that x equals to 14 times 2 over 9 times square root of 2. So we found out in conclusion that x equals to 28 over 9 times square root of 2 and y equals to 49 over 9. What is the area of the green trapeze ABDF? It equals to the sum of its sides, that is AB plus DF, times the height, that is AD over 2. AB plus DF times AD over 2. So AB, the area of trapeze, the green trapeze ABDF equals to AB. AB, it is y. AB, it is y, plus DF. DF is 9 minus y. So it is in total y plus 9 minus y times AD. AD is 2x. 2x. So it is 1 over 2 times y plus 9 minus y times 2x. 2 over 2 is 1, and y minus y is 0. So in conclusion, we found out that the area of the green trapeze ABDF equals to 9x. And x equals to 28 times square root of 2 over 9. So 9 over 9 is 1. So in conclusion, we found out that the area of the green trapeze ABDF equals to 28 times square root of 2 square units. So in terms of numbers, the area of the green trapeze ABDF equals to 39.26 units. So I repeat again, the area of this green shape or green trapeze equals to either 29 times square root of 2 square units, or in terms of numbers, the area of this green trapeze equals to 39.6 square units. Okay, thank you very much.